Hello everybody, I'm Jussi Ahonen from Geological Survey of Finland, and we will now start the session. Welcome you all to this session titled Sustainable Water Supply Using Managed Aquifer Recharge. This is an online session and the duration is 30 minutes. In this session, we will present what managed aquifer recharge is about and how it happens in practice. We will have two excellent speakers today, Jaana Jarva, Chief Expert from Geological Survey of Finland, and Aki Artimo, Chief Executive Officer of Turku Region Water. I wish a fruitful session to all of you and also welcome you to discuss and present questions at the end of the session through the chat. Those participants who will be present in Stockholm, please also meet us during the World Water Week at Finnish Water Forum booth 404. Thank you and join the event.
So thank you, Jussi, and good evening, ladies and gentlemen. So I will start our session with the brief introduction to managed aquifer recharge. So managed aquifer recharge is purposeful and controlled recharge of water to aquifers. In managed aquifer recharge, we are utilizing natural attenuation. So this means that we can use much less chemicals and we can use the water purification with cost-effective manners. The managed aquifer recharge provides a sustainable tool to reduce the aquifer vulnerability, to adapt climate change, and also to cope with the growing water demand. With managed aquifer recharge, we can support safe water storage underneath the ground surface compared to surface water reservoirs. And we can utilize managed aquifer recharge in many kind of geological environments and many kind of different climatic conditions. When managed aquifer recharge is carefully planned and implemented, we can ensure qualitatively uniform and also naturally produced water year-round. In Finland, we have over 100 years experience in applying managed aquifer recharge in over 25 different plants. So why using managed aquifer recharge? So with managed aquifer recharge, we can support overall water supply management by addressing imbalances in supply and demand and by storing fresh water for dry seasons. With managed aquifer recharge, we can also raise or stabilize the groundwater level where groundwater is overexploited, or we can enhance the natural aquifer recharge. With MAR, we can also improve the water quality. So we can, for example, control or manage the salinization and saline intrusion. And MAR can also be applied in flood impact mitigation and also in land subsidence management and ecosystem restoration. To implement MAR sustainably, that means that we require a lot of expertise and data on hydrogeological conditions of our study area. And depending on the quality of the infiltrated water, the so-called raw water, and the purpose of our managed aquifer recharge, we can apply different kind of methods. The selected technique depends on the used raw water. So are we using rainwater, surface water, or for example, recycled wastewater? It also depends on the hydrogeological settings, the overall hydrogeological settings. Are we in a sandstone area or in a glassy fluvial area? But especially the local hydrogeological conditions tells us what kind of MAR techniques we can apply. That is why we need a lot of information and careful studies of the geology, the hydrogeological parameters of our study sites, such as hydraulic conductivity and storage capacity. And we should also understand our groundwater flow patterns of our study area. In addition to hydrogeological conditions, we should know about the hydrological characteristics, so the topography, land use, etc. And also the local climate. What is our temperature? What kind of precipitation we have in our study area? And what are, for example, the seasonal patterns in our study area? In Finland, managed aquifer recharge is mostly applied for drinking water purposes to enhance the natural groundwater recharge. In Finland, we used, for example, sprinkler irrigation, that is about imitating natural rainfall and utilizing the natural attenuation of infiltrated water. The most common method that we have in Finland is the infiltration ponds, where we are infiltrating the harvested rainwater, surface water, stormwater, or even groundwater. Then we have applied well infiltration in many places in Finland. And also the induced and controlled bank filtration is one of the common MAR technique that is applied in Finland. Sprinkler irrigation is rather simple method, but it's not suitable, for example, in areas with high evaporation. Clogging can also be mentioned as one of the challenges that should be mentioned if sprinkler irrigation is applied. Infiltration ponds, you will hear more in our next presentation, so I will not go into the details with the infiltration ponds. Infiltration wells can be used to direct the infiltrated water directly to the aquifer, or infiltration wells can also be applied in a way where the infiltrated water is actually released into the soil, and we are utilizing the natural attenuation processes in unsaturated zone before the infiltrated water enters the aquifer level. And then bank filtration. So we can increase the aquifer's capacity by enhancing the natural bank filtration from river or from lake in a managed and controlled way. So it is essential to secure our water resources in climate change, in changing climatic conditions, and in socioeconomic conditions with the growing water demand. And with MAR, we can do it with cost-effectively, environmental friendly, and with climate-proof and sustainable manners. Globally, there is an urgent need to improve the water management practices and to safeguard the good water quality and sufficient water quantity for everybody. And based on our experiences in Finland and globally, we can say that MAR is a promising option to tackle these all challenges, and it's a good step towards the sustainable development goals. Thank you, and I will now move to Aki.
So, good afternoon to everyone. My name is Aki Artimo, and I work as a CEO of Turku Region Water Ltd. And today I am going to provide you with some information on how we apply managed aquifer recharge to provide good quality drinking water for about 300,000 people living in southwestern Finland. So our company is a wholesale drinking water company, which is owned by 9 local towns, of which the Turku is the largest ones. And we have secured the water production in the region as I mentioned, with the managed aquifer recharge for the coming centuries, I would like to say, because this is, as Jana mentioned, a sustainable way to produce water, but it's also you can continue with these natural processes for a very long time in the same target aquifer. And we're actually the second largest drinking water producer in Finland. In Finland, we have only about 5.5 million people. So obviously we don't have such a large drinking water companies, but our daily production rate is about 65,000 cubic meters per day. I would also like to mention that the whole MAR system that we use is also a multi-barrier approach, and we have used latest technology in that, and we can adjust the production according to the new research as we go along. So our company can also offer project consulting in MAR, designing, planning, and operation, but only at the advisor level. Okay. So then more details about the managed aquifer recharge, how we use that. So as I mentioned, in our case, we are using that to artificially infiltrate groundwater, and we're using that for drinking water production. For us, I would like to say that it's a very safe and also cost-efficient method. But the successful implementation of MAR requires a lot of expertise and data in hydrogeological, geophysical, and geochemical conditions of the study area, as Jana already mentioned in her presentation. But the Finnish water sector is able to provide with these sustainable solutions for MAR applications. And also Jana mentioned that this same method can be utilized in different geological environments and also climatic conditions. But then more detailed information about the area where we are working with. So during the previous decades, the Turku area has suffered from inadequate and poor quality water resources. And all of this changed after we implemented the MAR system there. And now, at this time, we have this MAR-based water supply system that meets the needs of the whole Turku region with 300,000 inhabitants. But what is the most important benefit from this MAR for us is that this method allows us with more than 10 times bigger production rates as compared with naturally formed groundwater in the same aquifer without any changes in groundwater quality. So here's a map and a couple of pictures of the whole system. So from the map you can see that we will take the water from the river Kokemäenjoki, which is in the northern part of this map. And that is actually almost 100 kilometers away from the actual consumers of this water in the Turku area and the surrounding municipalities. So in the upper row where we have these two images, there is this water intake plant taking the water into our pre-treatment plant, which we have built basically just to remove the solids away from the river water, because the river water quality changes throughout the year. So there are actually changes there, but we can basically just remove the solid materials from there, and then it's ready to be used for infiltration. In the middle row, there are two images of the actual MAR plant and infiltration basins, which we have more than 20 of those in this Virtaankangas Esker aquifer. And obviously we also do have these pumping wells from which we take the water up to be used. And in the lower row of these images, you can see pictures of the bedrock reservoirs and clean water basins. We actually have 3 of those in the area where we can store the water before we pump that to the consumers. So here's a picture of how it all works. The water, the pre-treated river water in our case, comes in from the left side of this image, and where we lead that to the infiltration basins. And from those infiltration basins, the water flows into the sand and gravel aquifer, and where the residence time of the infiltrated water is about 3 to 4 months. And during that time, the water becomes like natural groundwater in its quality, and the artificial infiltration of this groundwater actually imitates the works of the Mother Nature itself and is both ecological and efficient. And in our case, because we have very precise control of the flows within the aquifer, there's no water that gets wasted in the process. And what is also important to mention, that this whole system requires only a tiny fraction of the chemicals that are used in the traditional drinking water facilities. And then there are some points that I would like to mention. Also, Jana mentioned some of these, but these are important if you apply MAR throughout the world. This managed aquifer recharge method is cost-efficient technology for both small and large-scale water supply. It's also a very natural method, as I mentioned, with minor chemical use, and it's easily automated and remotely controlled process. If you remember the map that I just showed you, so our water production system extends for more than 100 kilometers in length, and this whole system can be operated from a single operating room, which is located in Turku. So the whole company basically has about 25 workers, and still we can provide water for 300,000 people with that stuff. What is also very important as it comes to MAR, so it has a very large subsurface storage capacity. In our case, we have infiltrated water available almost 10 million cubic meters at any given time. So even though we would not be able to infiltrate more water, which can sometimes happen when we have some maintenance work conducted in the pre-treatment plant, we can still continue pumping of the groundwater from the MAR plant. And this MAR method is also a very sustainable way of managing water resources. And adaptation to climate change is also very important, but also we can prepare for population growth. Because as I mentioned, we can use the same aquifers and enhance the yield of those same aquifers with this MAR method. And we can also restore and expand the existing aquifer capacity. So it's also a very safe solution for several common challenges, also mentioned before, which are raising or stabilizing groundwater levels. We can also prevent saline intrusion or land subsidence, and we can use this method to manage stormwater runoff and floods. And I would also like to mention that our Turku Region Waters MAR plant, we gained excellent sustainability index ratings, which were presented in the UNESCO MAR publication in year 2021. So basically, this was all I had, and I thank you for your attention, and we would be happy to answer any questions should you have some. Thank you.
Well, thank you, Jana and Aki. We are well on time here, so please give us comments and questions via the chat. We have here one question. Maybe this is for Jana, and if I think this already we got this during the Jana's presentation, but of course Aki can add something. But yeah, so the comment is, thank you for your presentation. Typically, is attenuation aimed at physical, chemical, or biological attenuation?
Thank you for the good question. Actually, usually the purpose is to utilize all of them. So when we are applying managed aquifer recharge, we are using the physical attenuation, for example, the filtering process of the soil. We are utilizing the different chemical processes we have in the soil, and we are also utilizing the biology, so biological degradation of the harmful substances. But I think Aki can also now tell what are utilized in Virtaankangas plant, what are the most important attenuation methods used there?
Yeah, so basically in Virtaankangas in Finland, our goal is to remove the organic carbon from the surface waters. As I mentioned, we have the pre-treatment, so it cuts almost half of the organic carbon already. But in Finland and in the Nordic countries, we have lots of organic carbon in the superficial waters, and the MAR method is really good in cutting that into suitable levels for drinking water. So there are some reactions going on. The natural bacteria in the soil is actually degrading the organic carbon there.
Okay, thank you for the question and for the answers. Now, and the second question is, how do you plan and possibly negotiate who will benefit from MAR, including water for nature and other using who are using the same aquifer?
Okay, so I might answer to that question. So in the aquifer that we are using, there are not that many people living in, but we had to take that into consideration. So there are some private wells, and with this MAR method, we have been able to, as I mentioned, restore the groundwater levels to a natural state. So basically, no one is harmed during these processes and during this production. And we have also taken into account the natural spring discharge rates, so that we have no harmful effects on those as well. And so basically the water that we use resembles the natural groundwater, and there's no degradation of the groundwater quality in any parts of the aquifer. And as I mentioned, the groundwater levels have been restored to a natural state.
And maybe I can add here also that in Finland, it's obligatory to have environmental impact assessment when you are applying MAR.
Obviously, and then we have lots of different authorities who are actually controlling what we can do, and we have to follow strict regulations on how to work with this MAR.
There was also one question about managed aquifer recharge versus large retention dams, and why MAR could be more beneficial than the large retention dams. So, like mentioned in both presentations, when we are speaking about groundwater, so we have the water underneath our peat. So it's actually there safe from the air pollution. So we can say that usually aquifers are saved from pollution much more than the surface water resources.
And also how we deal with the MAR in Finland is that we infiltrate the water all the time, and we pump it all the time. So it's not like storage and recovery. So it's an active process that is going on, and there's actually a constant flow of infiltrated water through the aquifer at all times.
Okay, thank you. And there was another comment of getting the emails. We will write them down. And then another question: what other countries are using your expertise?
So if you mean our expertise, so we have been working with some partners, for example, especially Geological Survey of Finland has been working in Vietnam, for example, but we would like to establish a better way to provide all the interested parties with this expertise that we have. So basically, our company is still working and based obviously in Finland, but we are building cooperation with the Geological Survey of Finland, obviously, and some other Finnish companies, so that we could provide with our insight of MAR to other countries and other water companies as well.
Yeah, then interesting that this works in Finland, but are there many places in Africa that it could work? Maybe I can answer that, also referring to the previous question. So we have had a preliminary project in Kenya, and we are in a early stage or final stage of proving a pilot project regarding MAR in Kenya as well. And certainly it's, as maybe said here also before, it's not geologically, or it can be applied in any geological circumstances, although it needs a very careful and throughout understanding of the circumstance. We have 3 minutes here, so one more question. Thank you for the presentation. For reference about the MAR in Finland, what scale is system? How big are the infiltration ponds? Do you use many wells to attract the water and so on?
Okay, that was actually a good question. Well, it depends on the site, because in Finland there are about 25 different MAR plants. Ours is the biggest one, and we have 22 infiltration ponds, and the size of those infiltration ponds are altogether a little bit more than 2 hectares. So a little bit more than 20,000 square feet altogether. And we have 13 pumping wells, and the yields can go up to 10,000 cubic meters per day for a single well.
But then we also have examples with the municipal water utilities that have only 1 infiltration ponds, and they are providing water for a couple of thousand of inhabitants. So the scale of the MAR can be really, really huge, from really small ones to the bigger ones, like the Virtaankangas MAR plant.
Yeah, so it's very flexible way.
Yeah, then there's one more comment. Thank you, excellent presentation. I can could say the same words to you. Thank you, Aki, and thank you, Jaana. Please join us if you are in Stockholm. So the booth 404. We will be there in Tuesday whole day, and also please join us for cocktails in the Tuesday eve. And anyone else online, we added the email addresses there of Jaana and Aki, and I will put also mine. So you please contact us anytime. Okay. Thank you. We are running out of time. So thank you for joining, and have a fruitful World Water Week and spring, autumn, wherever you are. Thank you.
Thank you. See you.
Bye-bye.